So we're going to solve a second differential equation. So a differential equation here is x squared plus 2x over 2y with the initial condition of 0, comma 2. So for this one, we can't apply the power rule for finding the antiderivative because we have two types of variables on the same side here, and we're not looking at a polynomial, so we can't use the add 1 divided by your new exponent rule. So we'll have to use the method of what is called the method of separation of variables. And there's four main steps. The first step is to separate the variables. The second step is to integrate. And third step is to solve for y. And then 4 is to just basically present your answer. So those are the four general steps for solving these type of differential equation. So I'm going to show each step for this one. We're going to get the general solution and the particular solution. So I'm just going to erase this. Okay, so we're going to do the first step, which is to separate. And what it means to separate is we're going to move all the terms with x's to the one side and the terms with y to the other side. So we're going to look at dy dx as terms as well. So the way we're going to separate here will look like this. So the first thing I'm going to do here is I'm going to multiply both sides by dx. And what that will look like is the dx will cancel on the left side. And so what my equation looks so far at that point is dy equals x squared plus 2x over 2y multiplied by dx. Then I want to move this 2y to the left side with the dy, so I'm going to multiply both sides by 2y. So now this 2y and 2y cancel, and now all the terms or factors that have y's are on the same side. So I'm going to clean this up. What we have so far is 2y dy equal to x squared plus 2x dx. So that's the separation step. And on the AP exam, we get 1 point for just separating the equation accurately. So step 2 is to integrate. So to integrate, I'm just going to copy the line we left off with. And to integrate, we're just going to integrate both sides by drawing in the integral sign or the long S. And what we have now are two integrals on the left side that we'll have to work out. So you can think of these as two sub-problems that we'll have to do. So luckily on both sides we have a polynomial, so we can use the add 1 to the x1 divided by the new exponent rule to integrate. So on this side we'll have y squared, and if I divide this 2 by the new exponent of 2, I'm going to get 1, and so we'll have plus c equal to, and we'll do the same thing on this side. If I add 1 to the 2, we'll get x cubed, and my fraction, my coefficient will be 1/3 plus x squared over 1 plus c. So these two constants here are actually different because we have two different integral problems we just worked out, but we can just combine them together. If I combine these together by subtracting the c1 on this side, they will just become one big constant. So we can just replace this with the big C. So far, my equation so far looks like this. Y squared equals 1/3 x cubed plus x squared plus C. So that's the second step, is integrate. The next step is we want to solve for C, and we'll only have to do this if you're being asked to, if you have an initial condition, and we do, which is 0, 2. So at this point, we've only have the, this what's called the, if we square root both sides, we'll have what's called the general solution. But since we have the initial condition of 0, 2, we'll have to use that to solve for C here. So what I'm going to do here is we're going to plug in 2 for y, and we're going to plug in 0 for x. So we'll have 2 squared equals 1/3 times 0 cubed plus 0 squared plus our c. And then this will give us 4, and then we'll have these two terms will become 0, therefore our c is 4. Now we can solve, we can finish solving the differential equation. So in step 3 and step 4, there's a lot going on here, and so it's hard to like say distinctly what the rule, what the steps should happen before these two steps, because they can overlap. So I'm just going to call this like solve for C, and then the fourth step will be present the solution. And when you're presenting the solution, you want to make sure the equation is solved for y. So our final answer should say y equals and not y squared. So I'm going to plug back in the c here into the general solution here. So we'll have y squared equals 1/3 x cubed plus x squared, and then our c is 4, so plus 4. Now I need to take the square root of both sides. And what we'll have is y equals, and it'll be plus or minus, since we're taking the square root, plus or minus the square root of 1/3 x cubed plus x squared plus 4. So at this point we have two solutions, y equals plus or minus square root of what you see here. But we'll have to decide which one it is, either plus or minus, because we know that the solution looks like this. There's only one equation that corresponds to this, the graph of this function, and the way we choose it is by paying attention to what our initial condition is. So remember that our initial condition was 0, 2, and we'll have to pick the positive one in order for us to get a positive 2 here when we plug in 0. So if y is going to be 2, right, and we're plugging in 0, and we're trying to get positive 2, we'll have to use the positive one. We can't use the negative one because our answer, our initial condition, doesn't have a negative 2. Therefore, our final answer, the particular solution or the specific solution to the original differential equation is y equals the square root of 1/3 x cubed plus x squared plus 4. And that's the solution.